Greetings. Welcome. My name is Kathy, and I am with the Friends of Arlington's Planetarium. Today is March 14th, 2021, which is, of course, Pi Day. I hope all of you have already had some pie today or are planning to a little later on. But it's more than that. It's also the birthday of Professor Albert Einstein. And we have, through the magic of the space-time continuum, which is a little blurry today, I'm afraid, managed to.
It's a very complicated system, so mathematics is to be understood.
We take what technology we can get. So Professor Einstein has agreed to join us as a celebration, a birthday brunch celebration. Bring your own, food and drink, sadly. But we're going to hear from the professor. And he's going to talk to us a little bit about his life and his work. So you can ask questions in the comment section, and the video will be available afterwards on our Vimeo page. So I'm going to let you talk to the professor here. And professor, if you need any help with anything, not that you would need help from me, feel free to call for me at any point.
I will be happy to do so. But guten Tag, everyone. It is a great pleasure to have been invited to support such a fine institution as the Arlington Planetarium, and I have apparently been invited here to help in part celebrate the day of my birth. So, as some of you may or may not know, I was born on this day in Ulm in Germany in 1879. And since I have achieved a modicum of fame over the years, it seems as though people are very interested in things like such as when my birthday is, which I find rather amusing. But let me perhaps share some of the messages I have sent with you, and that would be a good place to start. That I have received cards and letters from all over the world, it seems. Although I get so very much fan mail, I try to answer the questions specifically for those of the children, but I haven't looked at all of these yet. So perhaps you'll bear with me, and we'll see if some of these prompts some about discussion for today. So I have a card here, birthday card from Marjorie in Georgia, in the south of America, and it says, "Greetings, fellow Pisces." So the moon supports your connection to motivated Mars, and steady Saturn helps you tackle whatever comes to mind. Well, Martley, I thank you for this felicitations, but I most certainly assure you that the date of my birth has nothing to do with the motivation I might have to solve today's problems from the locations of Saturn or the moon. So, nonetheless, I thank you, but the true science, and the one that we are supporting today, is the science of astronomy, not the science of astrology. So it is understandable ever since the beginning of man, yes, we have paid attention to what is going on in the skies, and it was used as a way of keeping track of the time. So our very birthdays, which are now used by things such as horoscopes and astrology, are related to this notion that something that happens in the sky is connected to us. And in a way, it is, because the sky helps us keep time, yes? Unfortunately, thanks to the laws of Newton, we know that the only effects that the moon and Jupiter might have on me sitting here is the gravitational effects, and those are not very strong. So I'm sorry, Marjorie, I suggest that you perhaps visit your local planetarium to have some sort of enlightenment in the ways of astronomy. But I do have a letter here from a gentleman who says, "Dear Professor, best wishes to you on your birthday. I am an avid astronomer," and here we go, "and have always stood in wonder and awe when I looked into the skies. You have an observatory, or many, named for you, so you must enjoy astronomy as well. And this letter is from Robin, who is a school student. Well, yeah, I am interested in astronomy, yes, very much so. Now, I am a physicist by trade, yes, but if it were not for the astronomers, like the ones who we are working in collaboration with today, I would not be a very famous man, because it was thanks to astronomers that my theories were first proven. No, I had just recently mentioned Sir Isaac Newton, yes, and his theories of gravitation. Now, with this being said, we all understand that if you take an apple or a piece of fruit and drop it, this is gravity, yes? There's a force that pulls things down. But as you may or may not know, my theory of gravitation was quite different from Isaac Newton's, in that there was not a force between two objects. There was actually a more sublime explanation for this, and it had to do with the curvature of space-time. I apologize. Tiger, stop meowing at the door. The dog's not interested in you. I have a cat, and sometimes he misbehaves when we have company. Now, see, with the gravitational theories, it was proven in 1919, was indispensably supported by the work of astronomers, specifically one in England, a man named Sir Arthur Eddington. And it was my theory of gravitation that said that there is no force between the apple and the ground. It is a curve in space, as though there were a piece of paper and a heavy object was sitting on it and making it curve inward. Now, this was challenging, and we can talk about this for many hours, and I do not want to slow down the celebration and discussion of physics. But basically, it was astronomers who helped us prove that the light, as it passes through a very large object like the star, actually bends. And this is something that Newton could not explain. Pardon him, he was a wonderful man who was the mind of the millennium, but the tools he was working with, he could not determine this. And it was an astronomer, actually there was an astronomer in America, George Ellery Hale, who was a person who I addressed to ask if it was possible to see starlight bending around a star. Now, you might say this is something that is very complicated, yes? Well, indeed, it is a simple theory. It was difficult to prove, but the idea was simply this. If we were to look at a star off in the distance, let's say, and note where its location was, and wait until something very massive became near our field of view, perhaps the sun, it would change the position of the star off in the distance. So it would look to be slightly different when it came closer to the very large sun. Now, you might say to yourself, Herr Einstein, one cannot conduct astronomy when the sun is in the sky. Yes, and you are true. However, there is something related to astronomy that allows you to turn off the sun, and it is an eclipse. And in 1919, an eclipse was used to block out the sun temporarily, and the locations of the stars were seen to be imperceptibly different from where they were prior to the sun being in the visual neighborhood. And this was a very great discovery indeed. I found myself the next day, well, it wasn't the next day, it took several months. The eclipse was observed in April, but the proof and the calculations were presented by the astronomer Eddington in November, and the very next day, Herr Einstein became very, very famous. And that fame catapulted me to notoriety all over the world. And I have to say, it has been, I think that this fame, in a way, has made me rather stupid. Unfortunately, people come, and I had written a poem once, and it said something along the lines of, people accost me in the streets and they say, please scribble your name. I will hang it on my wall along with a picture now that I have met you. And I look at them and I think it's like, oh, these people are crazy. But perhaps it is me that is crazy. Who knows? Well, shall we proceed with another birthday greeting? Let's see. This one. This letter is from Joseph in Massachusetts, and he says, Dear Mr. Einstein, happy birthday. March 14th is my birthday too. I am 8 years old. My teacher says I am a handful. My mother sometimes uses different words than that. Do you remember when you were 8 years old? I like my science class very much. Enjoy your day. Do you have a pet? As a matter of fact, you just heard my pet cat, Tiger, who was making some fuss by the window. But it is a very long time ago since I was your age. But let me try to recall some of the important points. Now, my sister and I, when we were born in Germany, we were well taken care of by our parents. I was allowed to be curious. I had the freedom when I was raised to wander and play and experience things of my own accord. And I remember in particular, there was one very influential day, and I was about 7 or 8, maybe 9 years old. And for a present, my father gave me a simple compass. Now, you may find this mundane today with all of the wonders of our modern times, but the compass fascinated me. Because when one took a magnet and moved it around the compass, the needle would move by itself without being touched. No physical forces applied whatsoever. And if you went outside and you turned around, it would always point to the north. And when I was a child, this gave me a chill to my bones, thinking that there must be something deeply hidden in the universe, a secret that perhaps we can try to ascertain. Now, this is a very simple question that I have pursued all of my life. People ask me, Herr Einstein, how have you gotten so smart? How have you achieved such fame and such accolades? And these things are nothing. These are trappings of an adult life. The true aspect of this is to always think as though you are a child. Because the questions that a child asks are the questions that are the key to the universe. So mothers, perhaps Joe, when your mother, you ask her incessant questions and she says, because I said so, as an answer in her frustration of you asking many questions. You should always be polite to your mother, but you should always challenge whenever one says, because I said so. Because this is something that helped me throughout my entire life, throughout my youth, throughout my college days, and beyond. And speaking of further in education, I have a letter from someone in high school, it seems. And it says, Dear Professor, best wishes to you on your birthday. I am a junior in high school where I recently studied your series and found them very interesting. Well, thank you very much. What advice do you have for high school students as they prepare for future studies or just education in general? And this is from Anthony in Seattle, Washington. Well, as I had just mentioned previously, there are people, it is widely known that I was a bit of a handful when I was in school as well, especially in my high school years. And if a teacher ever told me that the answer to one of my questions was, well, that is because it is the way it is, or this is because this is what is written in the book. These are things that did not please me very well at all. I had always found that the notion of science being promulgated because of authority, because of some great scientists had once said this in the past, and thus it is true forever, this is a flaw, because there have been many instances in the history of science where someone has claimed an authority that has to have been challenged. Perhaps things, when we are speaking of astronomers, there was a time when we thought, according to the likes of Claudius Ptolemy and Aristotle, that it was the Earth that sat at the center of the universe. But thanks to Copernicus, who challenged this idea, we now know that the Earth is just a tiny planet orbiting a sun, of which there are many, many suns in the universe. So there was another example of when I was in youth, when I was studying physics in high school, they said that it has thus been determined by the time when I was in high school that light, the subject of fascination throughout my entire life, was something that was always in the form of a wave. And we still use this terminology today, but there was something that made me think, well, are we so sure of this? Because perhaps there is something to exploit here. Just the mere fact that someone says this is now an immutable law of physics makes me wonder, is there something there to explore? Now, sometimes if someone makes a mistake or there is a flaw in a theory, we sweep it away under the carpet and hide it and hope no one notices. But I, because perhaps of my inherent disdain for authority, would pursue the smallest detail, looking for a hole in a theory. And one of these appeared in the late 1800s when the theory that light behaves as a wave was challenged. And it was a very famous experiment, and we do not want to delve into the words of physics, but if you have the opportunity to study the Michelson and Morley experiment, which was deemed a great failure because it could not find what it was looking for, the fact that light would travel in certain ways through what was called the ether of the universe, which filled the space all around us. Now, this theory was declared a failure. It did not work. But I thought perhaps it does, that this is proving something, that perhaps light is not the way we thought it was. And this consumed my life, and I spent every single day thinking about what it would be like if I could ride on a beam of light and how the universe would be different. Now, that seems perhaps very childish, yes? But as I have told you, it is the childish questions that seem to unlock the doors that we can, whereby we can see the true meaning, the thing that is deeply hidden behind. So yes, indeed, when I was in high school, I rankled at the thought of authority. And alas, now, perhaps fate is rather cruel in this, because my disdain for authority has perhaps turned against me, because now people look to me as the authority. So perhaps fate is playing a very cruel trick on me. So, but I thank you for your question. And I don't know if any questions have arisen so far. Please interrupt me as I discuss.
Professor, do you see the question on the screen?
No, could you read it for me? My spectacles are a little bit.
Yes. John asks, even if you'd never made your great contributions through your work on relativity, you would have been recognized as an important scientist due to your work on the photoelectric effect and on Brownian motion. Can you talk about your work in those areas?
Absolutely. So the papers that were written in 1905, one of them was on Brownian motion. And for those of you who are wondering, since we're talking about a birthday and cake, it has nothing to do with brownies. Brownian motion was this notion that certain subatomic interactions between very small bits of matter had a rather random movement when observed. And this was on a very small microscopic scale. And this, without belaboring the point or going into a great depth of the history of the atom, one has to remember when I was in school, such as the young man who just wrote to me, the very existence of atoms was something that was still debated because they're invisible. Who would believe in something that was invisible, so small that we would never see it? So we saw that the notion that the Brownian motion paper was an indirect way of observing the fact that, yes, indeed, there was atoms, and their motion corresponded to things such as the kinetic theory of gases that was studied in the world of chemistry. And then furthermore, beyond that, you have mentioned the photoelectric effect. And the photoelectric effect is the reason why I was awarded the Nobel Prize in 1922. Some people think that, Herr Einstein, your theories of relativity are the ones that gave you all your accolades. But curiously, the paper on the photoelectric effect is the one that actually was noted by the Royal Academy, who bequeathed the Nobel Prize. And the photoelectric effect directly corresponded to this notion that light is sometimes like a wave and sometimes like a very small particle. I dub these things photons, yes? And this dual understanding of light helped to explain an entirely new realm of physics that was known as quantum mechanics. This was developed by a German scientist named Max Planck, and he realized that there was certain aspects to energy, and light is a form of energy, that had a granular effect as opposed to a wave-like effect. And the theory of the photoelectric effect and my explanation thereof supported this notion, and it opened this whole new understanding of the realization of how energy is transmitted. And this opens the world of something called quantum mechanics, which is rather interesting because I was just looking, and there is one of my notes here says, Professor Einstein, have you ever been wrong? No. Well, here is a case that is still being debated. Quantum mechanics, also it is an elegant and beautiful and theory that is being considered by some of the greatest minds in the world, like Niels Bohr in Denmark. It is something that rankles me because it introduces into the world of physics an element of chance. So in other words, as opposed to having a law of physics that is always one way or the other, there are aspects of quantum mechanics, which we could discuss for hours and hours to come, that basically say there are most things are just a probability. It is probable that this orange will not levitate from my hand, but there is a possibility that it could. So we have to consider that now. I think this is somewhat vexing. The notion that there is chance in the universe. God in Himmel, I do not like this. God, I think, does not play dice the way a gambler does. But there have been very great strides in this field, which perhaps shall prove me wrong. And this wasn't the first time. I remember with my analysis of the gravitational aspects of the general theory of relativity, so my mathematics had proven that the universe could be expanding. And this I thought was unlikely. And I erased the figures and changed them and introduced numerical operations that would keep the universe steady. And then some years later, another astronomer, Edwin Hubble, an American again, discovered that everything in the universe is moving away from us. So there I was incorrect. I went back to my papers and cursed myself for letting my suppositions lead me away from just simply following the truth. So yes, I have been wrong in the past, and sometimes you are noticed for some things that you don't expect you will be noticed. So maybe if there never was the eclipse in 1919, I still would have been a man of some achievement. But nonetheless, I think we should always be careful to be humble as we make our discoveries.
So, Professor, we have a question from Jennifer who asks, could you tell us a little about the cosmological constant and the overall structure of the universe as you understand it?
Well, this is what I have just spoken of. You see that when I was doing my analyses of the curvature of space-time, yes, that gravity is not a force that extends between masses across great distances as Einstein had proposed. And you'll remember that Einstein's theories, which were written in 1680s, I believe the Principia was written, that they had been working very well from the 1600s all the way to 1900. So this is uh, a very prominent statue for a little man with a hammer to come tick away some of the marble to try to change the theory. But Newton's theory said that it was between any two masses. So here is my cup of coffee, and here is my trusty tangerine. There is a connection between these based on their mass, yes? And that would pull them together the way the moon and the earth are pulled together by their gravity. However, the experiment that was done with Alfred Eddington and the eclipse, uh, the sun has a great mass, and it attracted a beam of light, but the beam of light has no mass. Therefore, we had to completely recalibrate our understanding of what gravitation was. And this included the mathematics, because it is one thing to come up with a clever little magic trick of saying, oh, the stars will move and you watch and see, and then I will be right. You must do the mathematics. And I must say that the mathematics of the general theory of relativity, which came after my 1905 paper on special theory of relativity, uh, the major difference between these two, although they share the same name, relativity, uh, was the mathematics was very, very difficult. It were it not for the fact that one of my best friends, Marcel Grossman, was an accomplished mathematician, I never would have had this discovery. In fact, there was another man in England named Haber, who actually was calculating my theory, and his mathematics was much better than mine. So there was a bit of a pressure for me to try to come up with the mathematics explaining how geometry would work if your piece of graph paper, let's say, so you imagine you take a piece of paper and you'll do your graphing in your geometry class, but if the paper was bent and curled in all directions, wouldn't that be much more complicated? Alas, it was. And it is in these mathematics that I came across the notion that the universe could have an expansion quality in it. And to me, this just seemed too unsettling. The universe seemed like it should be static in size. And so I introduced the cosmological constant. And this was a mathematical addition that essentially canceled out this expansion of the universe. Now, I had gone on this way for several years until Edwin Hubble discovered the shifting of the spectra of the light from many distant objects like galaxies, that it was shifted to the red. It is called red shift, but perhaps you are more familiar with it's known the Doppler effect. So if a train is coming to you, you hear the whistle as a very high pitch, and as it goes away, it has a very low pitch. This is evident with light as well. And Edwin Hubble realized that the universe is moving away. Essentially, its whistle is low pitched in terms of light. And this was something that I had to regret, that I had introduced this cosmological constant in error. But alas, the wonder of science, it is not based on any one authority. If Einstein was the authority the same way Ptolemy was the authority, it would be sad if there was never a Copernicus to come along and challenge this. And the facts discovered by Edwin Hubble challenged my theory. And as any scientist knows, that if the facts dictate that you must change your observations or change your theory, that your theory is, how should I say, beholden to the facts, then you are not a scientist if you are not willing to change your mind. And this was the effect of the cosmological constant. It provided me with a little dose of humility, which I have been said from time to time that I need such as this. I think perhaps we all do. Let's see if someone else has sent me any messages here. Oh, that one we've already read. And this one, we are making our way through. Oh, here's one. It says, "Dear Professor, I saw on the occasion of one of your birthdays, there was a party, and as you were leaving, took a photo of you sticking out your tongue, which I have found very funny, and I keep at my desk." Perhaps you have seen this. I have become rather famous for it. It looks something like... Now, it's very interesting. I was in the company of the actor, there we are, of the actor Charlie Chaplin, who I befriended on a trip to here in America. And we were leaving this presentation, and there was photographers everywhere and asking me this question and asking me that question, and it was very bewildering. And I said to Mr. Chaplin, like, what does this all mean? It's, and he said to me that, well, they hear me because everyone understands me as the funny scamp who falls down on the cinema screen. And they cheer you because they don't understand anything that you do. So it is an interesting dichotomy, is it not? And I just said to him, but what do you think this means? And he said, nothing. That's a very smart man.
So, Professor, Jim asks, Herr Professor, what predictions of your theory did you think would be the most difficult or even impossible to measure?
Oh, absolutely. One comes to mind that has apparently become very popular. It's the notion that if there is a curvature in space, and if you imagine if I had my napkin and it was laying here and I put something weighty in the middle and it would make it curve down, that our sensation of gravity is essentially trying to escape from this hole, right? And this curvature in space is rather confusing because it can look as though it were a force. An example I have used before, if you, let's say as a child, your favorite candy is jelly beans, yes? And you save all of your money and you buy your jelly beans and you take them home with you and you spread them all over the bed. And you decide to lay in the bed with your jelly beans the way Midas would lay in a pile of golden coins, yes? Now, as you lay on your mattress, would not you make an indentation? And the jelly beans would collect around your body. And you might say, if you were clever, that there is clearly an attraction between me and my favorite candy. And perhaps if you are good at mathematics, you could do something so as to write a mathematical representation of this force between you. And it would perhaps be very serviceable. It could explain the way the jelly beans move, so it would be of interest to you and candy makers and mattress salesmen alike. But alas, it was not true. But it did open an interesting aspect that the curvature of space, very quickly, it was asked of me, like, how extreme could this curvature be? And this was something that had been asked actually many years before. There was a scientist who lived shortly after the time of Isaac Newton, a gentleman named Mitchell in England. And he thought, well, if Newton could conduct the calculations to predict what it would be like to propel something into orbit around the Earth. Now, mind you, this is in the year 1687 or the likes. And Isaac Newton had predicted if we had the capacity to shoot a cannonball with enough vertical or horizontal speed, that it would essentially go around the Earth. I'm getting a lot of use out of my tangerine. And it would stay in orbit. Now, this forward thinking would not be realized until much later, the aspect of could we possibly use our technology to put something into space, which is something we have yet to see if it can be done. I'll leave that to you to answer. But this Mitchell said if there is an escape velocity from the Earth, what if that escape velocity was higher than the speed of light? And the speed of light, as we know, is 186,000 miles per second. Now, that is a very high speed indeed, but one can imagine going much faster than this. Now, could there be a curvature so deep that not even that speed would allow an escape, and thus you would have a dark star, as Mitchell called it? Now, this languished for many years as sort of something of fantasy, but as the realization that astronomers continue to find proofs of the curvature of space, the notion was that could one have a gravitational indentation in the three dimensions of space that no light would ever escape? And the answer is yes, this is possible. It would be a star from which light could not escape. Now, when I was asked if I could see if we would ever discover these black holes in the universe, I said to myself when I was speaking at a conference that it is possible that they exist, but it would be finding one would be as though you were trying to hunt for birds in the season when birds are not around, in a country with very little birds, and doing so at night. So it was very unlikely that we would find any of these mysterious gravitational dark holes in the universe. But perhaps, and as we are speaking through a quirk in the space-time continuum as it is, perhaps I can ask you if such a thing has indeed been determined to be true.
And Steve says, are you excited about the actual measurement of gravitational waves in the past few years? So across the space-time continuum, there has been actual measurement of gravitational waves recently. What do you think of that, Professor?
This is wonderful news. Well, I have been away from physics for too long. Yes, as you know, and again, referring back to our sheet that can stretch, yes, the mass of a sun in it. And if we think of the universe as this mattress with the weight in the center, if you are laying on the mattress and someone next to you was tapping it on the side, you might feel the vibrations in the bed if you are a light sleeper and feel like, what was that transmitting by? That was a prediction of the general theory of relativity as well, that there are gravitational waves, that there could be disturbances in the curvature of space-time, the fabric of space-time, as it were. And it would, of course, be something that would have to be truly massive to be detected or very close. But these variations, considering that perhaps some explosion of a star, some distant violent object happened many light years away, as those vibrations made their way through space, they would die out the way ripples in a pond die out over time, perhaps, yes. Now, these would be so very, very small that perhaps the entire Earth would feel a small vibration, a jiggle. Oh, something's like the width of an atom or even less. So this was far, far beyond the abilities of the technology of my day to discover this. But I find that the fact that physicists have accomplished this, well, further proof that the general theory of relativity was a pretty good idea, yes? I remember someone asked me once, like, "Yeah, Professor, what would you have done if the British had failed to detect the curvature of space-time and disprove your theory?" And my response was, and perhaps I was a little bit arrogant in saying this, it would be, "I am sorry for the dear Lord, because it is a theory that is too beautiful to be false." So perhaps my touch of arrogance is justified by the discovery of gravitational waves. So I am eager to hear if there are any other such, perhaps black holes have been discovered now. That would be fascinating.
Well, Professor, we don't have any more questions online at the moment, but if you've got one or two more, oops, we don't. Sorry, hang on a second.
I would love some
We
more
do
questions.
have a question from another Jim who asks, did you enjoy teaching at Princeton?
Interestingly, by the time I arrived at Princeton, this was an institution that was founded by Mr. Bamberger, a man who became very rich as a mercantilist. And his notion was, and it is rather contrary to the noble enterprise of teaching, was that if you come to the Advanced Studies Institute here in Princeton, you will just get to think all of the time and not burden yourself with grading papers and dealing with intransigent students like myself as I was in Zurich. But so my teaching responsibilities in Princeton were very much minimized, or how shall I say, specialized, so that the students that I was working with in Princeton were actually very, very accomplished physicists themselves. It was more like a collaboration than a classroom. Now, no, my degree in that I achieved in college was to be a physics instructor. But unfortunately, I was so, how shall I say, contentious with my professors that very few of them were willing to write to me a recommendation to be hired as a physics teacher. And this is maybe perhaps best. Well, I have to think that I would like to, the times that I did teach when I was in Berlin, I did try to do everything that my teachers did not do, because that was something that I thought that in the realm of education, the important thing is not to be militaristic in your approach. Germany was, as you know, my political affiliations are such that clash with my homeland very greatly. And the militarism and the staunch regimented notion of society that was prevalent in my days when I was there, it, how shall we say, transmitted into the way schooling was done. And this was such that we were told to respect the authorities. We were told to remember things in a rote fashion and never deviate by our own curiosities. And this is something that I just could not do. I could not do it in the classroom. I could not do it in society in general. This is the reason why, when I was still a teenager, I petitioned to have my citizenship to Germany changed to that of Switzerland, because this was something that I could not bear witness to. The Germans have always had a secret penchant for following sociopaths. And several years later, when we come to the 1940s, you can see that they mastered that skill very greatly with the advent of Herr Hitler. But this notion that teaching should be done more like the way you are not breaking a horse or training a dog. You are trying to do something like plant a garden and grow flowers. So the principles of education are such that one must treat a young mind, a student of any age, from a graduate student to a kindergartner, that they must be nurtured and watered and fed and weeded around and treated with kindness the way you would tend to your rose garden. And this is something that even in my limited days as a classroom teacher, in my later years, something that I still valued, and I would give that advice to any student, any teacher today, that we have the wonders of the age. Why should you memorize something that can be looked up in a book in 5 seconds? Spend your time thinking about the broader questions. And anytime, and if you ever see me conducting a lecture, and you hear me say something to my students, well, it is because that's the way it is. Or you should correct me and say, Professor Einstein, you need to stand corrected, because one should always ask these questions. So in that sense, I do miss my days as teaching with students, because it is electrifying, as always, to see those who will rise up and perhaps displace you and displace your theories. But this is not something that should damage the ego. This should be something that makes you proud as a teacher. So I hope I rambled a bit, so I hope I addressed your question.
So we probably have time for just one or two more questions, Professor, if you have any other birthday cards.
Let me see here. They come in from all over the area. There's one. Herr Einstein, how do you plan to spend your birthday? In very short, I would probably just take a nap on this sunny afternoon in the hammock. I have lots of hobbies. I like to travel. Well, I too like to travel. In fact, when I was a young man, in my early days during high school, I mentioned that I renounced my German citizenship. And at that time, my family had moved to Germany, where my father was running a factory creating dynamos, electrical generators. And I took up my rucksack and walked across the Alps over the course of several weeks, and traveled and saw the sights and looked at the mountains and breathed the air, and found that this was very therapeutic as well. So travel is something that I have always enjoyed as well. I had come to the United States in the 1920s, and this was before I even spoke English, and was fascinated by the reception that I received. I remember that, in fact, I was traveling in the American West, and I was a guest of the Hopi Indians, who gave me a wonderful, beautiful headdress to wear, and smoke a pipe with them. And those of you who know, I am very fond of smoking my pipe. And this was a whole new world, to think that someone, a little boy who plays with the compass in Germany, would someday stand with these great indigenous peoples of the United States. Beyond that, I took a tour. In fact, I learned of my award of the Nobel Prize. I was aboard a ship that was returning from a tour of the world. I was heading past from Japan back through the Suez Canal back toward Germany. And this was something that I found most interesting. So if I, in the years that I have left, have the time to experience the wonders of other lands, it is something that I always enjoy. So that is a good way to spend your years, yes? I have another note here. Dear Professor, for your birthday, I have written you a limerick. There once was a lady, Miss Bright, who could travel much faster than light. And in a curious way, she went out one day and came back the earlier day. Rather silly, but I understand the notion that time is something that is relative. This is something that some people have said when the newspapers came out and said that Einstein's theory was such that only 12 people on the world could understand this. I thought that was a bit of a overreach, because the notion behind relativity is such, and perhaps as we come to the close of our discussion here, it is like if you place your hand on top of a hot stove for a mere 10 seconds, it might take an hour. But if you spend your time in a cafe having a chat and a coffee with a pretty girl, well, that 5 minutes, that hour might seem only to be 5 minutes. So perhaps this is a very simple way of understanding that down deep, we all understand that time is relative. And as our time escapes us this day, that is a good point to end our discussion unless there remain some questions to be had.
I think that's all the questions that we have right now, Professor. I want to thank you for joining us across the somewhat uncooperative space-time continuum. We're having a little bit of trouble sometimes, but I think for the most part we got there, and that people were able to talk to you. I want to remind you that this is coming to you from the Friends of the Planetarium of Arlington's Planetarium. And that while the planetarium is currently not operating, we hope that once the construction project at the Ed Center is complete, that we will be reopening and better than ever. And we hope that we can find a way to get you across space and time to join us there, Professor.
I would be happy to be a guest.
All
And now
right.
I turn my
Well,
attention to it is time for my birthday cake. So
indeed.
I have been eyeing this for the last hour, so I'm getting rather impatient because of my penchant for sweets. The little girl next door, Adelaide, she comes over for help with her mathematics homework, and she bribes me with little pieces of fudge. It's one of my favorite days of the week. So I thank you
Well,
very much for your time and for listening to an old man ramble on his birthday.
happy birthday, Professor.
Dankeschön.